Ladies and gentlemen, my name is Jeremy Champa. Today we're going to be looking at the non-calculator section of the April 2019 SAT, and we are going to start on number 5. Okay, so the reason I'm starting on this question, I think the next couple questions have some interesting problems or some interesting features. So I'm going to notice these answer choices here first and foremost, and I invite you to do the same thing when you're taking a test. Now, it doesn't mean you have to spend a bunch of time staring at answer choices and wondering about the deep hidden meaning of these answers. Like, I haven't quite figured out, I'm sure some of you can do it on your own, figure out why 140 is there. I don't actually care that much why 140 is there. What I'm noticing is this thing about 8s and 16s and 64s, right? This is like, 8 squared, or 8 times 2, and this is 8 squared. So obviously there's a thing going on there. And it doesn't mean you have to, deeply analyze what that means. It just means that you're aware that obviously there's some mistakes involving, this idea that we have the root x plus 4 equals 12. Obviously this thing with the root and squared and times 2, that's obviously a thing, right? I could also notice that the 4 and the 12 add up to 16. Really what the math would be, right, root x is equal to 8 once we've subtracted 4 from both sides, right? We want to get rid of this 4, so we subtract it from both sides. And if the square root of x is 8, well, then x is not 8. And you could square both sides if you felt like it. That would be, x equals 8 squared, which is 64, right? So my point with taking a look at this question first, usually we start maybe a little bit later. The reason I'm taking a look at this question is because I think this is a common mistake. Look, if you're picking 8, then you at least might want to think about why 64 is even there, right? So, I'm not sure. Maybe the 140, oh, I see why 140 is there. You probably already saw it. But, if you extended this root and said the square root of x plus 4 all underneath the square root, then 140 plus 4 would be 144. The square root of that is 12. So all the answers come from a reasonable place, and by examining them at the beginning, you at least know what the most common mistakes are, and you're likely to avoid those mistakes. Okay, so let's see, we're going to move on here. Sorry, let me do this. Just moving some stuff around. Sorry, I got to do more stuff. I'm so sorry. Just moving some stuff around so I can see the questions here. Okay. So the next one we're looking at is number 6. And this is an interesting question. Again, what we have is this situation where you would have to do a ton of math if you didn't notice something. And that something is that instead of distributing the 7 and then the negative 2, which would be a big pain, I think what I would want everyone to notice is that 7 groups of 2x minus 5 and 2 groups of 2x minus 5. 7 minus 2 of these groups is 5 of these groups. So 7 of these things minus 2 of these things, of course, is 5 of these things, right? So I haven't distributed yet, and I didn't need to. I probably should have started just like I did the last one by noticing something about the answer choices. This thing about 65, so in the answers we have, 1, and then 15 over 2, and then 65 over 6, and then 65. So 65 is obviously a relevant number. I don't really get the 15 and the 2, but that's okay. Just 65 is the answer to D. So look, at this point, of course, there's a bunch of stuff you could do. I think personally, if I remember correctly, there's something else I could do here that maybe I'm not noticing, but what I would do is probably just distribute at this point and say 10x minus 25 equals 4x plus 20. And I want to reiterate, when you're about to do distribution, or when you recognize that distribution is a part of a question, know that that's a very common mistake. So make sure to, by highlighting that that's a common mistake, we're likely to avoid the mistake itself. Right, so if we finish this out, we'd subtract 4x from both sides and get 6x. We'd add 25 to both sides and get 45. And then we get x equals 45 over 6. And look, at this point I'm actually done, because 45 over 6 is not 1. 45 over 6 is not something else over 6, right? It can't be 65 over 6 because the denominators are the same. The numerators would have to be the same too, right? You could have 90 over 12 or all sorts of fancy stuff, but not something else over 6. And then 45 over 6 is, you could estimate and say, well, that's less than 10, because since 60 over 6 would be 10, 45 over 6 is even smaller. So it's definitely not a big number like 65, so I'm done. Of course, you could reduce it by dividing the top and bottom by 3, right? And then you would get 15 over 2. Okay, so the big thing I wanted to highlight with this question is that you can save time by noticing a pattern in the early work that that sort of eliminates the need for a bunch of calculation with this distribution. And distribution is a common mistake, so it's nice to make moves to avoid that extra work. All right, number 7. Yeah, so the middle of this test I think is fairly interesting. So there's a couple ways I would approach number 7. There's actually a lot here that I want to talk to you about, even if not all of it is necessary to solve the question and get the question right. They want to know what's equivalent to that. So the first thing I would notice here is what's happening with a. So x minus 2 squared, x plus 2 squared. If you've been doing some work in the SAT for a while, you may have recognized these components as the conjugates, the things that multiply to the difference of squares. So I'm going to rewrite this here, and I'll explain why in a second, but bear with me. I'm going to rewrite this as x minus 2 times x plus 2 times x minus 2 times x plus 2. So you're like, why did he do that? Well, because if you know the difference of squares, look, all that squared means is 2 of these, right? X minus 2 times x minus 2. That's both of these pieces here and here. And then x plus 2, here and here. So squared just means 2 of those. Multiply by itself. So I've rearranged them because I actually know that this multiplies to be x squared minus 4. And this multiplies to be x squared minus 4. That's the difference of squares concept. And it's a really, really useful concept because now I've avoided some work. I'll show you what I mean. Like when I finish this out, obviously what I'm doing here is it's convenient that this is answer choice A, because if you got to work on this, maybe, you could quickly do this work. Now you would FOIL this, you'd get x to the 4th, you'd get the outside term would be negative 4x squared, the inside term would be the same, and then the last term would be positive 16. And that does simplify to what we wanted in our answer. Now, it may not occur to us, if that was answer choice D, then it wouldn't be that helpful to just start going to work on 4 equations and then just cranking some stuff out. But I noticed something about answer choice A, these components, x minus 2 and x plus 2. I know how those work together, and I want you to be ready when you see those come up on the test. So let me explain to you why it was so important that I noticed that, and then we're going to talk a little bit more about 7, so bear with me. If I didn't notice that, let's say that I just did, x minus 2. I'll write it out like this. X minus 2, x minus 2, x plus 2, x plus 2. Now, those of you who have already studied with me, some would know that I tend to write things out that are polynomials or sort of expressions like x minus 2. If those things are squared, I would write them out separately because I know that I can FOIL them more accurately and more predictably if I write them out. So, if you multiply these two things together, you get x squared, you get minus 2x plus 4, and then that would be x squared minus 4x plus 4. Okay, that's still in parentheses because it's still getting multiplied by these things, which you could write out as x squared, 2x, another 2x, and a positive 4. And then you would get x squared, combining those two middle terms, 4x plus 4. And now you have 3 pieces. You can't just FOIL this. Now you have all this stuff to work on. Let me be careful here and just show you that those are 2 different sets of calculations right here and here. And that would be a lot of work and likely something that could easily go wrong. So noticing the difference of squares made it reasonable to approach this in a traditional way. Now, I wanted to mention all that because difference of squares is so important on this test. X minus 2, x plus 2 multiplies to x squared minus 4. Knowing that is super useful on this test. But I want to show you probably the way I would do this question from the beginning if I were trying it, for the first time on the test. I would recognize that there's a ton of calculation to be had if I do this question in a traditional way. So what I would do instead is I would use real numbers. So I would say, well, I don't know, let's try x equals 0. Well, then the whole thing gives me a 16. And if I look at answer choice A and try that out, that would be 0 minus 2. I'll just write minus 2 because we all know that that's what that works out to. That's squared. And then 0 plus 2, which is just a positive 2 squared. And that would be 4 times 4, or 16. So A works. However, B does not, because then we would have 4. Again, if x is a 0, I'm putting in x is 0, and I need to get 16 in order for it to be a right answer. Well, it would be 4 times 2 times negative 2, and that negative sign right there messes it up. 8 times negative 2 is negative 16, so B is out. Now, C would work. You'd have negative 2 to the 4th power, which again, when this gets tricky, you just write out negative 2 times negative 2 times negative 2 times negative 2, which is 4 times 4, or 16. So, cool. That one works. D does not, because you would just have negative 4 to the 4th power. And all you got to know is that negative 4 times negative 4 is 16. So times another negative 4 and another negative 4, that's just not going to work out. You don't have to know that it's positive 256, which I think it is. You just have to know it's not 16. So I'm down to 2 answers. And then what I would do is I would try out another number. So how about like x equals 1? If x equals 1, then we get up here, this would be 1 minus 8 plus 16. It's important to say this squared only relates to the x and not to the negative 8. So it's 1 to the 4th power minus 8 times 1 squared plus 16. So that's 1 minus 8 plus 16. A nice, easy set of math, which works out to, I think, 9? Right? 1 minus 8 is negative 7 plus 16 is 9. I think. So then you would look at answer choices, the remaining answer choices only. So let's look at A. If you had A and we have C as the other option. Well, if you have x is 1, then A would be 1 minus 2 squared, and then 1 plus 2 squared. And that's going to work out perfectly. 1 minus 2 is negative 1. Negative 1 squared is 1, and then 1 plus 2 is 3. So we're saying 1 times 3 squared, which is definitely 9. And answer choice A is right. I'll circle it in both spots. And C would be wrong because you would have 1 minus 2 to the 4th power, which is negative 1 to the 4th power. And that's not equal to 9. That's equal to 1. So it's answer choice A. So I know I just went over a lot there. The long and short of it is there's really 2 things that we're doing. We're recognizing difference of squares, which we didn't need to on this question, but it comes up a lot on the test. So I wanted to highlight it. And really all we're doing to solve this problem is we're using real numbers. I don't need you to be able to factor things that are in the 4th power. X to the 4th. You don't need to factor stuff like that. You just need to know difference of squares, and you need to use real numbers to get rid of answer choices. Okay. Let's keep going here. Number 8. The big thing about number 8 is the phrase in terms of. So it says D in terms of V and M. So that literally means get D by itself. And how do you do that? Well, you have V equals M over D. All you would do here, you could use real numbers if it helps you. You could call, if you wanted, you call M like 6 and D 3. And then that way, if you had 6 over 3, that would be equal to 2, right? 2 equals 6 over 3. So then v would be a 2. So you could totally do that and try out the answers and see which ones work. Like, for instance, A would be saying that d, which is 3, equals 1 over 6 times 2. So, of course, that's not right. So on and so forth. You could try all these out. Answer choice B would say that d, which is 3, equals 6, which is m, over v, which is 2. And yeah, that works. The other ones won't work. You could also, so there it is. Look, 7 and 8, both times you had variables in the answer choices. You can use them as real numbers, just assign values that make the equation make sense. Of course, I picked numbers that made the equation make sense. You can't pick like m is 100, d is -2, then v is not, 2 any longer. It's -50. Right? So you have to pick numbers that make your life easy. Of course, you could just do this in a more traditional way by saying if I want to get d by itself, I'll multiply both sides by d and get dv equals m. Right? To be clear, I just multiplied by d over 1, top and or both sides. These cancel, you get m over 1 or just m, and you get d times v over 1, which is just dv. Lastly, you would divide by v and get m over v, which is answer choice B. So that was number 8. Okay. So you can use real numbers when in doubt, anytime there's variables in the answer choices, almost every time. Okay, number 9. The answers we have are A is 3, B is 8, C is 12, and D is 15. And they want to know what's the distance traveled in miles. Distance in miles. So here's what we know. The total charge is $27. 27. And then the initial fee is $3. Well, that means the other $24 is left over, and that's this thing where they say, 40 cents per 1/5 of a mile. So that's kind of like a weird construction. What I would say is I would just say, well, multiply both of these times 5 and you'll get $2 for 1 mile. And once you know that, you're in pretty good shape. Because then you just say, okay, well, if I have $24 and it's $2 for 1 mile, you could set up a ratio. You could say 2 over 24 equals 1 mile over X miles. So I'll just write it so it looks the same, but really just 2 over 24, which you could reduce to 1 over 12, equals 1 over X. Well, of course, then X is 12. Right? The other way is cross-multiplying. So cross-multiplying means you multiply 24 times 1 and 2 times X. So you have 2X equals 24 times 1, which is 24, and divide by 2, and you get X equals 12. So 12 miles, right? The important thing is being able to set up a ratio. And when you set up a ratio, you have to be able to say things like, okay, dollars over dollars equals miles over miles. And you have to be able to say things like $2 for 1 mile, so 24 for X miles. And there's all sorts of ways you can set up as long as you can talk about it in that way. You could be like $2 per 1 mile is equal to $24 over an unknown number of miles. That's the same math. You'll notice when you cross multiply, you still get 24 equals 2x. Right? So hopefully that one makes sense to you. Let me know if you have any questions. I'm going to keep going. So number 10 is another question where they again just want us to get v by itself. They say, what is equivalent to v? What does v equal? All right, so we mentioned something earlier that I think is important here, which is that this little squared guy, that only is dealing with v. For it to deal with other stuff, you need like parentheses. You don't have that. Really what you have is 1/2 times m times v squared, and that equals mgh. So if you wanted, you could pick real numbers here. You just have to, you have an elaborate system you'd have to set up where like, I don't know, deal with the v thing first. Make v equal like, 2, or let's make it 4. If v is 4, then v squared is 16, and then let's make m like 2, so that we have, and then we would have 1/2 times 2 for m, and then v squared, which is 16, and that equals 2, and then we don't know what g and h are, but we got to make this work here, so let's see. Those things cancel, so then g, maybe we'll make g equal 4 and h equal 4. It's dangerous to make two numbers the same. I wonder if we could make one of them 8 and one of them 1. It's also dangerous to make something 1. But you could do this, and you could try out the answer choices. I'm not going to belabor the point here. If you had these values here for each of these, you could just plug them into the answer choices and see which one gives you the v value of 4. Right? So that works. You could do that. What I would do in this case is, actually, I think it's simpler in this situation, even though you have variables in the answer choices and you can use real numbers. I think it's simpler to just do some of the work here. So look, you have m on both sides. You could cross m off. If you're not comfortable with that, you don't have to do that at first. So I'll skip that at first. Multiply both sides by 2. When you do that, it cancels here. You get mv squared equals 2mgh, or any order of those things. Convention is you put the numbers first, but you don't have to. You can say mgh times 2. Then you could divide both sides by m, and you get v squared, and you have 2mgh over m. That's where they cancel out again. Now, if there was addition here, if it was 2mgh plus, or 2mg plus h over m, you couldn't just cancel this out. You'd have to say, maybe that cancels and you leave the h over m thing alone. So that would look like this. You'd cancel the m and you'd leave an m here, right? So you would have divided both things by m, canceled it out, and left h over m. That's not what we have. We have something much simpler. 2mgh, and then divided by m, we just can cancel out the m's because it's all just multiplication. So we have 2gh now, and then we just take the square root of both sides. The square root of 2gh. So answer choice C. All right, so now we're past the halfway mark of this test, and we're really past the 2/3 mark for, this is the 2/3 mark for the multiple choice, right? Now this is one I just want all my students to just memorize what's up with 30, 60, 90s. So like, if this is 4 and this is 60, then I know that this is 4 root 3 and this is 8. There is a proportion of sides of a 30, 60, 90, which is always the same. That's 30, 60, 90. 30 is across from the shortest side. Whatever that is, we'll just leave an x there, but in this case it was a 4. Whatever that is, times root 3 for the long side across from the 60, and the hypotenuse is whatever x is times 2. So that's, the answer is just 8. Answer choice B. All right. Moving on. Number 12. The 30, by the way, let me back up and just say the 30, 60, 90 idea comes up so much. Be ready. It's at the front of the test, so you could just look it up, but it's a waste of time. Just learn it. It's not that hard. Let me just back up and tell you how I learned it, just to be clear. There's 3 angles. Yeah, you're like, every triangle has 3 angles, dummy. Yeah, I know. All triangles have 3 angles. This one has the 30, 60, 90, and it has 30, 60, 90, 3 different angles and a 30-degree angle, and it has a root 3 in it. The other one that you have to know on this test, so I shouldn't have deleted that, but I'll move over here, would be a 45, 45, 90. So if you have a 45, 45, 90, oops. 2 equal angles means we have 2 equal sides, and then the hypotenuse has a root 2 in it, x times root 2. So I just remember 30, 60, 90, 3 different sides, 30 degrees, root 3. This one, 45, 45, 90. There's a 90-degree angle here. You have 2 equal sides, 2 equal angles, and a root 2. So that's just a little memory game I use. Okay, so now to number 12. This question, if you look at the answer choices, you have like plus or minus something over something. This is looking a heck of a lot like the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. That's all you got to do on this question. So that's based on the idea of standard form. So if you can get a parabola to look like this, anything with a squared to look like this, then you're good. In this case, 4, and they say v squared plus 6v plus 1, it's a 6 here, not a b, 6v plus 1 equals 0. People will be like, what about the x's and the v's? It's just a variable. It doesn't matter which one it is. So don't let that throw you off. So you just plug this stuff in. B is a 6, so negative 6 plus or minus the square root of b squared, so that's 6 squared, 36, minus 4 times a, which is a 4, times c, which is a 1. Okay, all over 2a, which is just 8. Now look, you actually don't have to finish this problem out. I mean, maybe you get to the point where you just do the math underneath the radical and you say 36 minus 16, so that's 20, and it's over 8. At this point, I want you to be able to estimate and say, okay, it's definitely the negative sign. So if you look at A, B, C, and D, C and D are out because they have a positive 3. We have a negative 6. And obviously, you may be able to see the relationship with negative 6 and 8 with negative 3 and positive 4. Some people get confused here with why this 20 gets reduced the way it does. So let me get to that. Let me move this chalkboard over a little bit. Give us more space. So here, I'll do this up here. I could reduce this. Well, let me actually, instead of reducing it, let me first just write it this way. Negative 6 plus or minus. I'm going to write the square root of 20 as the square root of 4 times the square root of 5, which you can do. Maybe the intermediate step is 4 times 5 under the radical over 8. And then you can write that as negative 6. You can break it up like I was just going to do over 8. Then you could reduce the 4, or you could rewrite the 4, not reduce it. You could write it as 2 root 5 all over 8. And then you could say, well, look, that's negative 3 over 4 plus or minus 2 over 8 is the same thing as just 1 over 4. And then the 1 just doesn't need to be written. So that's why it's answer choice A. But what I would say is, even at this point, you could say, how the heck is it going to be a 13? There's no way this is going to turn into a 13. It doesn't make any sense. So for that reason, you could be done. You could say the sign up front tells me that it's answer choice A or B, and then the radical is not going to get to 30, so it must be the 5. That's a totally fine way of doing this question. All right, moving on. 13 is interesting. I've mentioned to folks before that words like per and each and every refer to slope. The thing is, every one of these answer choices uses that. Right, so let me see if I can actually write these letters. I'll put them down in the corner here. A, B, C, D. Okay, so the way I start questions like this is they say, what does 50.25 represent? And I go up to the original, C of t equals 50.25 t plus 228.75, 228.75. Okay, and I just say, it's the slope. But then every answer uses words like per and each. So then I say, what's the slope? It's the change in y divided by the change in x. What is y? It's cost divided by change in x, which is years. So it's, and to be specific, it says the average cost per square foot in dollars of a condominium in city X can be modeled by the function. So that means that the C is the average cost per square foot in city X for a condominium. That's on top, divided by years. So A is really just what C of T is. The average cost per square foot in a condominium. In 2001, oh no, actually, that's when T equals 0. because t is years after 2001. So this is another, answer choice A is the y-intercept, which is actually 228.75. Answer choice B is the value, it's really C of 9 years later, so it's C of when t equals 8. So it's the value when t equals 8. That's not what we want. We want slope. And then C and D just flip each other. So we want cost. It's not the increase in years divided by the cost. It's the increase in cost divided by the years. Notice where the word per is. It's cost per, or I'm sorry, so the word each, cost for each after the year. So this situation means cost divided by years. No doubt these words could confuse you, but in this case, that's what's happening. So I hope that's helpful. I always think of these as like, give a wise ass answer. It's the slope. What's the slope? Oh, it's rise over run. What's rise over run? Change in y over change in x. What's y? Cost. What's x? Years. In this case, what's maybe even an intermediate step would be, what's y? C. What's x? T. Okay, well, what's C? Cost. What's T? Years. Either way, those little small steps that get you to the point where you understand exactly what you're looking for in the answers before you go and just kind of juggle the answers. I see people juggle these answers before they actually know what they're looking for, and that's where mistakes occur. Okay. So, 14. 14 asks us to add 6 plus 5i plus 8 plus 3i squared. And that's just 6, 5i, 8, and then this can be rewritten as 3 times negative 1. So that's just negative 3. And so we're adding 6 plus 8 plus negative 3 plus, I'll write the 5i back here. So these three things add up to be 11, and then the 5i just stays the way it is. So the only thing we have to know is that I squared is negative 1, and then do the math. So answer choice A for 14. Okay, 15 is an interesting one. There's a couple ways of doing it. I'm going to show you a bunch of stuff on 15. First of all, the first thing you would look at is that you have a y-intercept that's been given to you of positive 2. That means when x is 0, y is 2. But every single answer choice has that. So we can't use that to get rid of any answers. They all have a y-intercept of 2. So there's a couple things you could do here. One is you could just, what I would do personally, which is I would use the parts of the quadratic. That is, when you write out the quadratic, what you actually have is two very useful pieces that work together to give us, the entire solution, which is to say the values for when this is 0, right? The roots, the spots where it crosses the axis, whatever those are. So in this case, I could use the outside, which tells me the x coordinate of my vertex. The reason I care about that is look at the answer choices. They have different spots where the bottom is, right? Where is the vertex? The vertex is, in this case, the minimum value. It could be the maximum if the parabola opens in the other direction. Okay, so what is negative b over 2a? Well, again, so this is the standard form where ax squared plus bx plus c. So a is just a 1, b is a 2, and then c is a 2. So what's negative b? Negative 2 over 2a, which is just 2 times 1. So just, this is negative 2 over 2, negative 1. That's the x coordinate of my vertex. Well, I'll tell you what, that's definitely not c and d. Those have positive x coordinates of their vertex. And it's fairly clear that it's b. If you weren't totally sure, what you could do is plug this value of the x coordinate of the vertex, negative 1, back into your function. So that would be, let me make a little space here. That would be, y equals negative 1 squared plus 2 times negative 1 plus 2. ran out of space there. There we go. So that would be y equals 1 minus 2 and then plus 2, which is just positive 1. And only one answer choice has a vertex that has a negative x value and a positive y value. And that is answer choice B. So that's the way I would do it. A couple other things I want you to notice here, however. So I use the x coordinate of my vertex. I'm going to just circle this part to show you that I'm going to end up using this as one of the ways I could help myself solve this problem. Not that it's the fastest way, but this other part tells me the number of solutions. Number of solutions. So I'm going to clear the board and tell you what I mean. That's called the discriminant. It tells you the number of solutions. Whether there's solutions, it's where we hit the x-axis. Notice in answer choice B, we never hit the x-axis. So there should be 0 solutions. So I'll show you what I mean. I'm clearing the board. Y equals x squared plus 2x plus 2. Quadratic looks like this. All over 2a. And we're talking about this piece. So if this piece is positive, 2 solutions. If this piece is 0, there is 1 solution. If this piece is negative, there's 0 solutions. Solutions. Okay. So why? Why is that the case? Well, look, plus or minus a square root. If you have a positive square root, then yeah, like say you had, 36. We dealt with that one earlier. Then that would mean you add and subtract 6. If you had plus or minus square root of 0, well, whatever negative b in 2a is, just plus and minus square root of 0 doesn't change anything. So that's only one solution. One solution. If you had a negative square root, we don't know what to do with that. Say it was negative 36. We don't have any tools to work with that, so there's 0 real solutions. Sorry for my terrible handwriting. 0 real solutions. And that's all we care about here is real solutions. Real solutions are x-intercepts, roots of equations, spots where we cross the axis. Okay, so that was a quick explanation of the discriminant, but how does it get used here? Well, again, you just use b, which is this 2. Sorry, the chalkboard won't let me get rid of that part. But b squared, so that's 2 squared, which is 4, minus 4 times a, which is just a 1, times c, which is a 2. And look, 4 minus 4 times 1 times 2 is 8. That's a negative number. And that means negative. Can't spell very well today. Negative. So that means 0 solutions. You could say that means 0 x-intercepts. And that would mean answer choice A is out because A has 2 spots where it crosses the x-axis. And you could say answer choice D is out for that same reason. Now, you'd still have to do some work to figure out what B and C are, but I'll show you what you could do in that case. If you don't know which one's right with B and C, try out what happens when x equals 0 or when x equals 1. Because look, if you look at answer choice B, you have like this spot, which is 2, and I'll write it here. And then things get bigger really right away. This is answer choice B. Answer choice C, you could notice, so this is still number 15. Let me write that up here, 15 still. For C, you have this value of 2, but then you have things getting smaller when x gets a little bigger. So what I would say is, what happens when x equals 1? If I didn't know about these other things that I've already shown you. So what happens when x equals 1? You get y equals 1 squared plus 2 times 1 plus 2. Well, that's bigger, right? That's y equals 5. All right, well, this looks like here's about 1. This is a smaller than 2. That's probably wrong. And this one gets bigger right away. So maybe that's, y equals 5 when x equals 1. Okay, answer choice B. So you could use estimation there. All right, so on to the grid-ins. 16 is about just knowing that this phrase A is a constant. means a is a number. That looks confusing. A is a constant means it's a number. Just a fixed, unchanging number. A equals a number that doesn't change. My handwriting is really bad today. Okay, so look, all that means if they say f of a equals 0 is it means a is an x value when y equals 0. All right, and there's 3 spots where that happens. 2, 4, and 8. Okay. I'm going to keep going here. So number 17. 17 is the situation where you don't have to do all the work. You could do all the work here. Let me give myself space to actually do this. 5x plus a plus 3x squared minus a equals 3x squared plus 5x plus 4. You could do all the distribution here, right? 5x plus 5a. Make sure that you actually nail the distribution because you know that that's an easy mistake to make. 3x squared minus 3a, and it still equals all this stuff. And then you could just combine like terms. You could be like, well, look, subtract 3x from both sides. Those cancel. Subtract the 5x from both sides. Those cancel. And what we have left is 5a minus 3a equals 4. That was my point at the beginning. You didn't have to do all that other work. All you have to notice is that a doesn't deal with x's, never gets multiplied by x, never gets multiplied by x squared. It's just the number at the end, right? 5a minus 3a equals 4. Okay, well that means, combine these two. It's just 2a equals 4, right? And then a should equal 2. As long as I did that right. 5a minus 3a is 2a. 2a equals 4. A equals 2. Cool. All right. So that's a question where you don't have to do all that work if you can just recognize how a is getting used in the question. All right. So 18 is a situation where they try to mess with you with this M1, P1 business. All that means is some point, like the MP coordinate plane, doesn't matter. It really doesn't matter. All this is a system of equation. You could totally think about this as 3x plus 2y equals 24 and x plus y equals 10. That would be exactly the same thing. They're looking for the y value because they say m1 comma p1 is a solution, and they want to know what is p1. All right, well, look, it's just a system. 3m, 2p, 24. Since I want to solve for p, remember, I'm like wondering, what is p? All right, well, I'm going to get rid of the m's. So we have m plus p equals 10. I'm going to keep the first equation exactly the same, and the second equation I'll multiply by -3. And then when I combine these, by design, I'm canceling these two out. So then I've got -1p when I add these two up equals -6, and then p equals +6. So it's just a system. Have the confidence to know that like p sub 1, it's just a point. This is where it comes from. It comes from this idea. Think about slopes. They say the equation for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What does that mean? Well, it means there's this one point that the x and y go together, and there's this other point where the x and y go together. That's all those sub 1s. The subscript is what you call these little numbers. They don't mean anything. But they just mean the key points together so you don't get confused about other stuff. In this case, it doesn't mean anything. In life, it might mean something, but in this case, that's just there to confuse you. Okay, 19. The big idea on 19 is make sure you're clear every time I do a question where I ask about some kind of intercept or something equals 0, or I'm like, what is an x-intercept? Oh, it's a spot where y equals 0. Any spot where y equals 0 that the line crosses, that's an x-intercept. So then all we have to do in this question is say 4x minus 5 times y equals 0 equals 2, and then solve. So 4x equals 2, because this is just a 0. X equals 1/2. 2 over 4, which is equal to 1/2. So not a hard question, but a question that's easy to mess up if you get confused about x's and y's, which we all do. So take active measures against that mistake by, every time I do this question, I'm not joking with you. Every time I do it, I in my head, I'm like, oh, is x-intercept? That means y equals 0. And it's really good to just draw it out. All right, so number 20, the last one in this test, in this section. Here's what you need to know to begin with. This equation is the standard equation for a circle, and it tells us that the center is 6, 3, center, and it tells us that the radius equals 5. So I have made some other videos about that. I'm not going to go into great detail about that, but think about it like Pythagorean theorem. The difference, x and y here are points on the circle. So the difference between some point on the circle and 6, that the difference between the x coordinate and 6, think about that as like a horizontal line from 6 to wherever x is. And then this is from 3 up. Maybe I'll do it like this so you can see it this way. From 3 up to the y value, and then this distance here would be your radius. Actually, it doesn't work when you look at it like that. Let me do it like this. Here it is. Here's our point xy. And we could say that this is, x minus 6 is this distance from here to here. And then this distance is y minus 3. And then the radius is 5. So think about it like Pythagorean theorem. This thing squared plus this thing squared equals 5 squared. So that's the important background information for number 20. But what's happening, I'm not going to draw a whole circle here, but what I'm going to draw you is we know that this center is at 6, 3, and I'll just kind of draw roughly where that is. You don't need a really nice graph for this. And you know that the radius is down 5. So we know there's a point down here, which is 6, -2. And we know there's a point up here, which is 6, +8. Because these distances of 5 are the radius. So, right, your circle kind of looks like this. I'm not even going to try to draw it that well, but, you get what I mean. Okay, fine. I will try to draw it decently well. Let's see if this works. We'll see how good my rough sketch was this way. I think my sketch was pretty decent. Here's the original circle. Now what we want is this word tangent. For our purposes, all that means is it hits it once. It hits once. Hits once. And we want to shift this thing down. So what we want is this point, 6, 8, to end up down here. So now our circle kind of looks like we may run out of some space here. We're going to run out of space. But now our circle is down here. Okay, well, what happened? We moved 8 units from 6, 8 down to 6, 0. That's 8 units. Right? Because we want the top of that circle to hit the x-axis once. So we need to move the top point of our circle all the way down to 6, 0, 8 units. Well, that means our 6, 3 moves down 8 units to 6, -5. And now use that information. I'm going to move over a little bit. Use that information to create a new equation. So you have, in the problem, they give you x minus 6 squared. And then they say y minus 3 plus a squared. Y minus 3 plus a squared equals 25. Okay, well, look, this thing right here, y minus...
I don't understand.
That was my Google, because I said the word okay. Y minus 3 plus a. Look, I already said that this center actually has to be this point. So the actual equation is x minus 6 squared y plus 5 squared equals 25. That's knowing the equation of the circle and knowing the signs are opposite. Here's the center, 6, negative 5. So I just put it into this equation. So look, these things have to be the same. Y minus 3 plus a has to equal y plus 5. Okay, subtract y from both sides. And then you have negative 3 plus a, so I'll add 3 to both sides. 5 plus 3 is 8. The whole idea is, what does tangent mean, and then knowing how the circle equation works. I've seen a lot of people make mistakes when they're kind of just like, oh, you add 8 or you subtract 8. It's like, look, it is 8, but I think it's very important to be clear about what that a is doing. Okay, so I hope that was helpful. If you have any questions, please get at me, whether it's, texting me, emailing me, yelling my name to the heavens and hoping that I respond, leaving mean or delightful comments in my YouTube videos, finding me on social media and trolling me, whatever it is, get in touch. I would love to hear from you, whether you have good things to say or whether you're like, hey man, this didn't help at all and I'm mad at you. That's cool too. Let's talk it out or type it out. Do whatever you want. Anyways, happy studying. I hope this video helped, and look forward to helping you more if I get a chance to. So until next time, take care.